All right, this is for those who missed class today. I'm gonna go ahead and go over the lesson. So the warm up was 5 minutes, 5 to 8 as usual. There are explanations on how to find this stuff already in Google Classroom, so I'm not going to touch on that. All right, but for today, what we did, we went over arc length and area of a sector. So arc length is measuring the length of this arc. We know the measure of this arc by the degree measurement. However, today we went over the actual length of this arc. In order to find the actual length of this arc, we need to be able to find the ratio of this degree measure by the entire circle multiplied by the actual circumference of the circle. And so when you see this equation, S is equal to N divided by 360, then N is your arc measure, meaning your angle measurement from the central angle and the arc. Your 2 pi r is just the equation for circumference. So as we go over these equations, you'll see a lot of this N divided by 360 times 2 pi r. So for this first one, we're saying with a circle of radius 4, what is the length of an arc that has a measure of 80 degrees? And we're just going to simply use the equation. So we have S is equal to N, which is 80, divided by 360 times 2, our radius, which in this case would be 4 pi. And here we're just going to try to simplify all the constants. We're going to leave pi as is for right now because there's no need to get into that detail. It's hard enough just trying to figure out what the actual simplification of this is. And so 80, and this will be 8. So 80 times 8 will give us a total of 640 divided by 360, right? So that's pi. And from here, we're just simplifying 640 divided by 360. So you can figure out what multiples of 640 are, right? So if I do 640 divided by 8, I get 80. Then I break 80 down, you know what I mean? And we'll end up with 16 over 9 pi. So the answer here will be 16 over 9, right? The sweet thing about this is I've given you a tool in here. So if you click on this circle within the Pear Deck, a new screen, a pop-up, and it will be an actual unit circle. And you can drag the line for the degree measurement and actually type in the radius to go over that aspect. All right, let's go over another question. Very similar. However, this time we have pi radians. And so for future references, within the unit circle, starting at 0, if we go to 90 degrees, that's pi over 2. If we go to 180 degrees, that's pi. If we go to 270, that's 3 pi over 2. And if we go to 360, that is 2 pi radians, right? So when we're talking about pi radians, that's going to equal 180 degrees. So our N in this case will be 180 divided by 360 times 2 times the radius, which is 6 pi, right? We already know that 180 is half of 360, so I could just convert that to 1/2 times 12 pi, and we know our final answer is 6 pi, because 12 divided by 2 will give me 6. All right, so within the Pear Deck, you have 4 slides to do. So this slide right here, you have your circle definitions. There are a couple definitions that have been added to the circle definitions. Also, there are some information on that first slide when we were talking about arc length. You'll get that information from there. Arc length and area of a sector. Again, the definition is in our circle definitions slide in Google Classroom. Now, how to find this? You would simply just use the equation. The equation is written for you right here. And you just want to substitute. Degree measure is in. The radius goes for R. And then you just simplify and leave it in terms of pi. Same thing here. We went over what 2 radians was. And so 2 radians will be your N. So find out what degree, remember what degree measure that was, and put the degree measure 2 times your radius, which is 8, and solve for terms of pi. Right. And so now area of a sector. So the area of a sector, the area of that sector is bounded by 2 radii and an intercepted arc, right? And so we have this arc measurement right here, and then we have these 2 radii. And so it's going to be a very similar equation. For this one, you're going to have the area is equal to N divided by 360. Same fraction because we're still dealing with a circle and the degree measurements within the circle, especially that arc. And then you have pi r squared, right? So pi r squared will be the area of a circle. We're taking a portion of that area of the circle. So that's why you have N over 360. So let's go ahead and go over 2 examples. And so for this one, I have A is equal to 165 divided by 360 times my R, which is 3 squared, 9 pi, right? And so I know from here that 9 and 36 are, I can divide 9 into 36. So I have 165 over 40 pi, right? I already know 9 could go into 36 4 times. I got a 0 left over, so 9 goes in 360 40 times, right? And then I can reduce from here. I know that 8 or 5 is in common with both of these, so I'm left with 33 divided by 8 pi. And that's our answer for that one. Going over another one just to be a little bit more comfortable, a little bit more flexible with it. So we're just going to substitute in again. Our N is 59 in this case over 360 times R squared. R is 10 here. So we're multiplying it by 100 pi. I know that 59 times 100 will give me 5,900 divided by 360 pi. I have 2 zeros, so I can cancel those zeros out. And so now is where I need to go in and simplify, right? And so I could divide 36 into 590 to figure out what I'm going to get. And that's pretty much how you're going to end up simplifying. Figure out, what they have in common, what are common multiples of 36 and 590. And our final answer here will equal 295 divided by 18 pi. Right? And so that is what we covered today. That is what we went over. If you go to the last slide, it'll take you to a link to Google Classroom. There is an assignment in Google Classroom talking about the arc length, arc measure, area of a sector. There are 2 questions on area of a sector. You have to pay attention to the details of it, but if you got any questions, just let me know.